Hello, in this video we're going to be talking about shifts with trig graphs. So really just shifting sine and cosine curves. Now what I'm going to start off talking about, this isn't exactly in your packet. If you turn to page 9, something similar to this is in your packet, but not really. So I'd rather have you just kind of like ignore the packet for a minute and we'll get there in a second. All right, now the first type of shift we're going to talk about is a vertical shift, which is also called displacement. All right, vertical, we know if something's vertical, it's up and down, okay? So we're going to talk about what shifts a sine or cosine curve up or down. All right, now if you look here, okay, we're given the graph y equals sine of x, all right? It's starting off the point 0, 0. It goes up to a height of 1 at pi over 2, back to a height of 0 at pi, down to a height of negative 1 at 3 pi over 2, and then back up to 0 at 2 pi. So this is y equals sine of x, which you can see over here. Look, this red curve again is y equals sine of x. Now, when you add a number to the end of a sine curve or a cosine curve, all it does is it shifts it up that many units. So since this is y equals sine of x plus 2, we just took this sine curve and we shifted it up 1, 2 units. Okay, so you can see, instead of this being at 0, it's now up at 2. Instead of this point being at a height of 1, it's now all the way up here at 3. Okay, we shifted it up 1, 2 units. Okay, so all we did was when you add a number to the end of a trig curve, of a trig function, it just shifts it up that many units. And if we had, instead of this plus 2, if we had a minus sign, like if this had minus 2, it would just take our sine curve and it would just shift it down 2 units. Okay, so it would be down over here. Okay, so if you want to read through this, I mean, this pretty much is what it says at the top. If you're given sine of x, if you're going to shift something vertically, you would add a constant number to the end, okay? If that constant number at the end is positive, like we had here, it would shift it up. If this was a negative value, so if we had sine of x minus 1, it would shift it down that many units. Okay, now in addition to trig curves, being able to shift up and down, they can also shift horizontally, which we know means left and right, okay? And that's called a phase shift. Now, I'm just going to start off with the rule up here. See how it says to shift a graph horizontally, we would take f of x equals sine of x, and we would change it to f of x equals sine of x minus c, where c is some constant. Okay, so if we had, f of x equals sine of x minus pi, then what would happen is we would be shifting it pi units. Okay, now let me show you how this works. All right, so let's look at this. It says y equals cosine of x. This is our basic cosine curve, okay? It starts off at a height of 1. When we hit pi over 2, we're at 0. When we hit pi, we're down at negative 1. And then it works its way back up to 0, 3 pi over 2, and up to its starting point at 2 pi. Now, okay, so again, this red curve right here represents y equals cosine of x. Now, see where it says it's x minus c? C tells you how far you're shifting it. Okay, so see how this says x minus pi over 2 units? What that means is instead of starting, right, the cosine curve starts high, instead of starting at 0 on the x-axis, we're going to shift pi over 2 units over to start it. So we're going to shift over to pi over 2, and that's where the start of our cosine curve is. Remember, a cosine curve starts high, drops all the way down, and then comes back up again. Okay, so what I did was I drew a dotted line here. I'm just making that like our imaginary shift line, okay? So since we're starting our cosine curve at pi over 2, remember the starting point of a cosine curve, it starts high, drops low, and ends off high again. This cosine curve, I'm going to go in a different color, it would look like this. This would be one complete cycle. Now, I know it comes over here as well, but isn't that because a cosine curve or a sine curve? It just keeps going and going and going, okay? Sine and cosine curves are cyclic, which means they follow a cycle, okay? That cycle repeats itself over and over and over again, so they just keep going. Now, one other thing I want to point out, and I don't want to get too deep into this right now, because we will get into this as we progress further into the packet. If you look at this cosine curve that was shifted pi over 2 units. Look at this blue curve. Look at from here to here. Isn't that just our sine curve as well? Look at that. So this curve right here is the same curve as y equals sine of x. So y equals sine of x and y equals cosine of x minus pi over 2 actually are the same exact graph. And we're going to learn that any sine function, any sine equation can also be written as a cosine equation and vice versa. Again, I don't want to get into that too much now. We're going to talk about that a lot later, but I'm just kind of putting that in your head right now, that sine and cosine curves can be rewritten in terms of each other. Okay, so now I'd like you to open up your packet to page 10. And what we're going to do is we're going to take a look at this right here is the format of a more in-depth sine or cosine curve. This is the format of a curve that has been shifted horizontally and vertically, or, it could be one or the other. But it says over here what everything stands for. I'm also going to label that right on my equation. So if you can do that as well, that would be great. Okay, so I just like to label. So what's in front of the sine or cosine? We already know is the amplitude. We learned that already. The frequency we know is the number that comes in front of the x or after the sine or cosine. This is a new component that we just spoke about, okay? If you have x minus some number or even x plus some number, this number in here helps you with your horizontal shift. And then if you have a number being added or subtracted to the end of your function or to the outside of what's going on here, this is your vertical shift. This tells you how far up or down we're going to shift. Now in number 20, we're given this equation. Okay, so we want to take a look at this equation and just line it up with everything that's here and answer these questions below. Now the only thing I'm seeing different about my equation is here we have parentheses within parentheses. So what I just did was I just rewrote this. I mean, technically, if there's a number in front of the x, isn't there really just a 1 in front of the x? So I rewrote this. You don't have to at all, but I rewrote this so that we have parentheses within other parentheses. And the reason I did that was just to make the b stand out, okay? And again, since we have no number in front of the x, it's implied that it's a 1. All right, so what I'd like you to do is I'd like you to just hit pause and see if you can determine all the values in this first column right here. All right, so the amplitude, we can see right here the amplitude is the number in front of the word sine. So in this case, it's going to be 3. Okay, so that was pretty straightforward. The frequency we already know is this number that's in front of the x. So this is a 1. Okay, so none of this is new. The period we already know that we can't tell from looking at an equation, but we know a formula for it. Okay, if you recall from the previous videos, period is equal to 2 pi over the frequency. And since we know the frequency is 1, 2 pi over 1 just simplifies to 2 pi. Okay, now, the next thing says the horizontal shift. Now, if you look up here, it says x minus the horizontal shift. So x minus, that means the horizontal shift is pi over 2. And I'm just going to put in parentheses, or not in parentheses, I'm just going to explain what this means. What that means is that we're going to be our graph is going to be shifted pi over 2 units to the right. Okay, our graph is going to be shifted pi over 2 units to the right. Do you guys remember from shifts earlier on in the year? If there's a minus sign in the parentheses, you're shifting to the right. If there's a plus sign in the parentheses, if this said x plus pi over 2, we'd be shifting pi over 2 units to the left. Okay, so a minus sign means we're shifting to the right. A plus sign means we're shifting to the left. Okay, and then down here, the vertical shift. The vertical shift is just this number at the end, which in this case is -2. Okay, and let me just circle all of our answers. Since there's a negative sign, what that means is we're shifting 2 units. And in this case, this time it's going to be down. Okay, if it's a positive, we're shifting up. And if it's a negative, we're shifting down. Okay, now I just wrote some formulas at the top of the page here that you're going to see. We'll see these formulas later on in the packet, but it's really important to know these. So if you could just hit pause and just write these on the top of your page, or not on the top of the page, just right where I fit it right here, that would be great. Okay, now up until this point in the packet, we haven't had any sort of shifts. We haven't had horizontal shifts. We haven't had vertical shifts. So if you wanted to know the minimum or maximum height of the graph, we knew that based on the amplitude. Like if there's no shift and the amplitude is 3, the maximum height is going to be 3. And the minimum on the graph is going to be -3. But when you have a graph that shifts up or shifts down, that's not how we're going to find the min and the max anymore. We're going to use these two formulas. Okay, so let's start with the minimum. To find the minimum that, along the minimum y value that our graph is going to reach, we're going to use this formula, vertical shift minus the amplitude. Okay, so the minimum is going to be equal to, well, we said that the vertical shift is right here, okay, is equal to -2. And then we're going to do minus the amplitude. And we know the amplitude right here is 3. So -2 minus 3 is -5. That's the lowest y value that our graph is going to reach. Okay, now the maximum height of the graph. Now we can use this formula. It's really the same thing, but with a plus sign. The maximum is equal to your vertical shift plus your amplitude. Okay, so again, our vertical shift is -2. And this time we're going to add to that the amplitude, which we already said was 3. So -2 plus 3 is +1. So if we were to graph this, right, basically, let's say here's 1 and here's -5, our graph would fluctuate between a height of +1 and -5, okay? So it'll go up and down between -1 and +5 because our graph is shifted 2 units down, okay? This at -2 is the middle of the graph, okay? The middle of the graph is going to be at -2. So the graph is going to fluctuate between, 3 units up from there, 3 units down from there, 3 units up from there, 3 units down from there. Okay, so the amplitude is the height from the middle line, from the midline. Okay, so let me get this out of here. That way we can answer the rest. So the next part asks for the range. The range just means how high and how low it goes. So we've already talked about that. It's going to fluctuate between -5 and +1. So you could write this in one of two ways. You can write it in interval notation, where we would put -5, we put the lowest point, and then a comma, and then the highest point. And because these points are included on our graph, do you remember we would use brackets? Okay, the other way you could say that, I'm going to leave it like that. That's how I like it. The other way you could say is that y is between -5 and +1. So you could say that -5 is less than or equal to y, which is less than or equal to 1. Okay, you can do it in step builder notation like this using inequalities. Okay, so y is in between -5 and 1 inclusive. We underline these because those values, y values, are included on our graph. All right, the midline. The midline is, we just actually talked about that. That was the middle height of our graph. So the vertical shift is what helps us find the midline. Here, let's put this formula here too, okay? The midline. I don't know if this is actually a formula, but if you want to find the midline is just y equals whatever your vertical shift is. Okay, so here, our midline, let me just go back to blue, would be y equals, and our vertical shift is -2. So that would be the middle height of our graph. Okay, that's halfway between -5 and +1. Okay, don't worry about the graph at the bottom of the page. I kind of wanted to do that with you, but I feel like I just don't want to cover too much at once. I just want to talk about like what means what in the equations in this video, and we'll actually graph them as we move forward in the packet. All right, so you can turn to the next page, page 11. Okay, so what I did here was I just wrote the format of our equation up here, and I got that from the previous page. I just stuck in the word cosine instead of sine because this says cosine. So what I'd like you to do is rewrite this at the top of your page, and if you hit pause, I honestly think you should be able to do pretty much all of these, so try it out. Okay, so let's see. If we look at our equation, we know the amplitude is what comes before the word sine or cosine. So in this case, it's 2. So our amplitude is 2. The frequency is what comes before the x or after the sine or cosine. So in this case, that's also 2. And the period, we can't tell by looking at the equation, but we do know a formula for it, okay? The period we know is equal to 2 pi over the frequency. So in this case, since the frequency is 2 pi over 2 simplifies to just pi. And just to remind you, what that means is if the period is pi, the period is how long it takes to complete one cycle. So it's going to take pi units to complete one cycle. Okay, now the horizontal shift. Now we know within the parentheses it's x minus the horizontal shift. Now this says x plus pi. So since it's, let me just actually write this out. Since it's x minus the horizontal shift, isn't x minus negative pi the same thing, right? X minus negative pi, isn't a minus negative a plus? So here, x minus negative pi is going to be our horizontal shift. So for horizontal shift, we're going to put negative pi, okay? Please don't put pi. Okay, basically what you do is you just take the opposite sign of what's in there. So if that says plus pi, you write minus pi. On the last example, let me just look back. In the parentheses, it said x minus pi over 2. So we put positive pi over 2 as our horizontal shift. Okay, so this just has the opposite sign. Now, just like the last one, I just want to write down what that actually means. So what that means is if it's in the negative direction, doesn't that mean we're going to the left? Or think about this. We've always learned if there's a plus sign within the parentheses, doesn't that mean we're shifting to the left? So this means our graph is going to be shifted pi units to the left. Okay? All right, now the number at the end here gives us our vertical shift. So here, our vertical shift is going to be positive 1. Okay, now let's move over here. We know the minimum. So our formula, I'll write it this time. The formula for minimum is the vertical shift minus the amplitude. Okay, so the vertical shift we found over here is 1. And the amplitude we found over here is 2. So it's just going to be 1 minus 2, which is equal to negative 1. Okay, the maximum is the vertical shift plus the amplitude. So again, our vertical shift is 1 plus our amplitude is 2. So when we add those up, we get positive 3. So just to remind you, what that means is if we were to graph this, our graph would go as low as negative 1 on the y-axis and as high as positive 3 on the y-axis. Okay, so our graph would fluctuate between heights of negative 1 and positive 3. Okay, so the x-axis is no longer the middle of our graph. The middle of our curve occurs wherever the vertical shift is. Right, we had to shift 1 unit up to graph this. So I'm just going to put like an imaginary dotted line here. This would be the middle height of our graph. Okay, the graph would go, if this is the middle height, remember, amplitude is the height from the midline. So if this is the middle of our graph, the midline of our graph, and the amplitude's 2, don't we go 2 units up to get to 3? And then from here we go 2 units down to get to negative 1. Okay, so this is the middle of our graph. All right, you know, while we're talking about that, I'm just going to jump to midline. So midline is the middle of our graph. It's this right here. Okay, so it's y equals, remember, any horizontal line is y equals, and since it crosses through the y-axis at 1, it's y equals 1. And if you want, we said on the previous page, the midline is just y equals whatever your vertical shift is. Okay, so our vertical shift is 1. All right, let me come back up here to the range. So the range, again, is how high and how low it goes. Okay, so I'm going to write this. I like writing an interval notation. I like to say, so we're going as low as negative 1, and we're going up to 3. And because we are going to reach both of those y values on our graph, I'm going to put them in brackets. okay? And if you do prefer to write it as an inequality, you could say -1 is less than or equal to y, which is less than or equal to 3. Either one is fine.